Welcome to Namespace Podcast. I'm Jordan, and I'm here with my co-host Derek. Today we're going to talk about test-driven development. We'll start off with some, introductions, like definitions and history, and then we're going to get into just some discussion about our experience with TDD and different topics such as like integration versus unit testing and code coverage. And some of these topics are very opinionated. Like there's no real answer to all of it, which is what makes this such an interesting topic. Except for my answers. I have all the answers. No, we're still trying to figure out a lot of this stuff. Honestly, there's so much. It changes from scenario to scenario. Like you really have to use judgment, like a lot of judgment when testing. Right. I think we kind of want to subtitle the episode, "The number one best practice is to not be dogmatic." Yeah, exactly. And as we read through a bunch of articles and looked at this, don't be dogmatic. Yeah, that's basically, that could be a subtitle for this whole episode. Yeah, so I think going back to it, test-driven development was first kind of started by Kent Beck in 1990. I want to say was the year. Or the 90s, I forget. Yeah, so somebody says he invented it. Others say like they rediscovered test-driven development, which... There's two kind of definitions we liked. One was from Martin Fowler and the other, again, personal hero of mine, Uncle Bob. Mm-hmm. So run us through the definition Martin Fowler gives. Yeah. So from Martin Fowler's website, we found test-driven development is a technique for building software that guides software development by writing tests. Follow 3 simple steps repeatedly. Write a test for the next bit of functionality you want to add. Write the functional code until the test passes, and then refactor both new and old code to make it well structured. So that's pretty much the process. It's a very simple concept, writing your tests before you code and then code until it passes. It's a very simple concept, but then there's so much detail that we're going to get into. Yeah, and really, Uncle Bob's isn't much different. Yeah. I got this from his Clean Coders videos, and I think he talks about red-green testing is when he brings this up. But it's, you write just as much of your test as needed to make it fail, and then you write just as much of the unit under test to make it pass. And you go through these iterations until you get the full test written. And I guess I'm going to save the benefits of doing that until we get to that planned section. But it is really just that process that, Martin Fowler had. Right. Write your test first and then make your test pass. Mm-hmm. I think that's the simplest way to put that. Yeah. Let me see. What else do we have? Well, so kind of a historical look there. We talked about it starting in the 1990s. Yeah. Back in 2014, there was a big article written that TDD is dead. And then I've noticed over the last 2 years, really, a lot more articles coming out saying that TDD is bad or TDD is dead, or, I'm committing to not doing TDD anymore for whatever reason. And now we're here today doing this podcast to settle all of the fights and all of the misconceptions about TDD. Mm-hmm. This is like the birth of Jesus. We will measure years. It is like from that. This podcast. I'm so confident that we've done so much research. So we did read a lot of articles. We were trying to kind of figure out what the argument against TDD was. And basically every article that says TDD is bad or TDD is dead includes countless disclaimers to, but I don't think it's bad. It's like, that's the title of the article. Yeah, the best one was everybody, and I mean literally all of them say, I don't have anything against writing tests, I don't have anything against TDD in general, and then they'd pick one specific issue that they had, but all of them had those super clickbaity titles of TDD is dead or why TDD is bad. And
in the one that was titled Why TDD is Bad, I think in the conclusion, I don't remember the words exactly, they basically said TDD isn't bad.
Yeah.
And it was really funny.
So what we've discovered is everybody's argument against TDD is that people are doing it wrong. That's a very common one. So it's like,
or people are being dogmatic.
Or people are being
and
dogmatic.
We refer to our subtitle for the episode.
Yes.
The number one best practice is don't be dogmatic.
Exactly. So those are the two, I guess, arguments against TDD, is just that people don't know how to do it right, or people try so hard to do it perfect that it becomes a nightmare. And this can be like over mocking, like writing way too many mocks and then your tests become over complicated, or in doing it wrong, for example, like not letting your tests fail first, because that's very important in making sure that your tests are actually testing what they're supposed to be testing, right? So if you don't do that, then it's like, well, then you're not really doing TDD. That's not an argument against TDD being bad. It's an argument against somebody not properly implementing TDD. So
yeah,
those are just a couple examples, but
yeah, I would say as an industry, like as a whole, we like tests somehow, and we're about to get into this because as Jordan and I were talking, we found out that Jordan doesn't do TDD.
Yeah, it's sad. We'll get into it.
But all that being said, she has some of the best tests I've ever seen.
I do think about my tests really hard.
Yeah, the best and the most tests I've ever seen. So we're not going to falter too much. We're going to forgive her.
Yeah.
For not doing TDD, because she's going to start.
I'm going to start working on it.
Give it a shot. But some of the TDD being done wrong is because people get definitions wrong. Mm-hmm. And I think the one that causes the most is the definition of unit. Yeah. And for me, actually, that was a big one, because I was of the very dogmatic mindset. A unit is this function of this class, or something of that granularity. And then my personal hero, Uncle Bob, tweeted something out. We actually wrote down the tweet. If you want to you can read the tweet, since you're the person that takes notes and I wing everything. Which one? Look at that. I can read it.
Derek can read it.
I'm gonna cheat and use Jordan's notes. Okay. The word unit in unit testing usually just means small. Other than that, the word has no agreed definition. Some TDDers call them microtests to stress the smallness. I prefer programmer tests because using TDD, they are written by programmers for programmers. Yeah. And so that was just like mind blown epiphany for me of, I used to get so angry at integration tests because they weren't unit tests and they slowed things down and they had difficult setups, which was always like a watered down argument for me, because I'm like, well, sometimes they're really not that difficult to set up. Sometimes they're easier than my mocks and my unit tests. But I was dogmatic. Unit tests, you can't do that.
Yeah, make it as tiny as it can be.
Yeah. And then, Uncle Bob just shatters my world with a tweet.
Yeah. Well, now...
But I like his definition. And I think if we adopt that definition for the rest of our conversation here, it's going to bring a lot of context to some of what we're doing or some of what we're saying. Yeah.
Because I guess, like, by that definition... the idea of a unit test versus an integration test it kind of becomes difficult to draw that line. Like, if your test is testing, you're testing one class, but it calls another class. Is that an integration test because the two classes are integrated, or would it would still be a unit test by this definition, because it's just kind of like one use case, one bit of functionality, or like one behavior per se. So the line becomes a little fuzzy between unit and integration. Besides, like we were talking about, when you're integrating two systems, like
a database.
Now that's certainly integration.
My I kind of just off the cuff pitched a definition for integration test, which was any test that crosses an architectural boundary. So if you're testing across the REST framework or you're testing across a database, something like that becomes an integration test. And things that stay all within your code is a unit test.
Yeah.
That's kind of.
But then there's also like the argument where you're like, okay, so I hit my REST API endpoint, and so I hit my controller, and then it goes to my repository, and then it goes to my, well, now I hit a database, I guess. So now it's not integration anymore.
And you also hit the REST endpoint.
Okay, yeah.
But so if you're just testing the controller, which you can, like in most frameworks, you can construct an instance of your controller, call that function and pass in a mock request object. And as long as you stop it in, your repository, and we're assuming using the repository pattern here, we're not talking about a Git repo.
Oh yeah.
That I would consider as a unit test, because we've not crossed an architectural boundary yet.
Okay, so now we have a unit test, right? And now the question is it worth it to like make this mock request and make mock out the repository, or is it more valuable just to hit the endpoint and go all the way through the system? What do you think? Do you think, like, I would say that
it depends on how complex that controller is.
Yeah. This is where TDD and unit testing and code coverage and all that just becomes like very you have to think about it in terms of your scenario, and that's why it's so hard, and that's why people have so many problems with it, is there's not like a clear-cut definition for unit or a clear-cut definition for how much you should mock.
Right. There are diminishing returns as you become more dogmatic with those standards. Yes. So as you push more for the 100% code coverage, you start losing value on tests and things. And if you get too dogmatic with they have to be units and no integrations, and you mock and you never use a database, that's going to be diminishing the value of those tests. And part of our job as an engineer, and I will be heard saying it a lot, why we get paid so well, is that we make the engineering choices, which is the balance between perfection and value, and we make them at the right places. And I think we can make that, again, a mantra for this episode is it's an engineering choice. You know your situation better than the rest of us, so just make sure you're making good decisions. Mm-hmm.
Yes. So we just hit like a bunch of different little points that we've been discussing for a while now. But another topic that we talked about a lot before this episode and did a lot of research on is trying to figure out the difference between TDD and BDD. Well, so we've talked about TDD, test-driven development, and then BDD is behavioral-driven development. And there's just so many similarities, and it was very difficult to pinpoint a clear-cut differentiation for a while. And we finally came to a conclusion, and we'll see what you guys think, if you guys agree, because we did a lot of at us, because we want to know what y'all think about our clear-cut definition, because it's so many articles are out there, and it's so difficult to find the difference. But well, this is what we've decided. BDD is a subset of TDD, where
suited for QA teams,
where you are, I'm trying to think of a specific word, where you are acting as the end user. You're carrying out a behavior or a scenario. That's behavior-driven development. And then test-driven development would be, the programmer test, the test that you write, that a programmer writes for programmers, where you are considering the implementation first and foremost, where you're considering how you're going to write your code, and you write your tests in such a way that you test the functionality you are about to implement. but now I'm coming back. So the one thing that's very similar that we found between BDD and TDD is both argue the concept of writing your tests before you write your code.
Well, yeah, they're both driven development. So
in
doing
BDD,
this drives the development,
right,
which means it has to happen first.
So in BDD, I guess you write just like the English plain behavior that is expected before you write your code.
Yeah. So jumping back to when I was getting a computer science degree, we had a software engineering course, and it talked about something very similar. And I thought it was use cases, and you'd have these two columns, which is user does something, system responds with this, user responds this way, system responds this, and you just run that down, and you would have a use case like that. And it seems very related to BDD. Mm-hmm. And so, it's just plain English writing down, this is what the user inputs, this is what the system outputs. It's kind of black box testing.
Yeah. Yeah, man, go ahead.
TDD is kind of white box testing. You're in the box and you know what's going on. But it's all written down first.
Yeah, I guess I've never worked on a team that does BDD because I wouldn't know, like, I don't know where you're supposed to put these behavior, like the behaviors that the developer writes down beforehand. I'm like, I don't know what the system is for all of that. Like, TDD makes a lot more sense to me, but I'm not sure.
I think it comes through sprint plannings and design meetings and stuff like that.
The behaviors given to you, maybe, or you. Yeah. So I don't have have you done BDD, do you think?
Yes. I've worked on a project that said it did BDD, and it was really TDD with just a fancy framework.
Okay.
Okay, cool. At the time I was like, that's BDD. That doesn't seem too different. I like this. This is cool. But from what we came down with is what BDD is. No, I've not worked on a team that does that.
Right. Well, yeah, if you're on a team that does BDD, definitely hit us up and let us know what you're actually doing, because I'm curious. Yeah,
and finding actual articles that describe the difference between the two and included code samples was so hard.
It was it just sounded like the same thing every time they said a difference. It was like, you're saying the same thing. But one of the main differences that we kept finding, which we mentioned, but TDD is your mindset when writing that test is you're thinking about the code implementation, and your mindset when you're writing a BDD test is you're thinking about how the end user will be interacting with your code, which means it is for testing the front end primarily. Like, you can't really, your user's not going to be interacting directly with your back end code. So BDD is for front end testing. But yeah, it was a very...
The best I could come up with was Selenium Testing.
Yeah, like Selenium.
Which I've never written a Selenium test in my life, but, it kind of makes sense.
Yeah. And then in that case, it's like, well, are your automation engineers who are writing Selenium tests supposed to write the test before you start coding? Because if it's... I would assume that it's just you write those instructions, like the manual test sort of worded instructions, like user does this, system responds with this, user then does this. I would assume that it's just the plain English words that are written before the code. Because I would think QA would come in second, but I don't know. I mean, TDD is much more of a broad concept, I would say. Like BDD is a subset, so it's a little bit more difficult to pinpoint it.
100% agree with that.
Yeah. But anyway, definitely hit us up at namespace.pod@gmail.com with your input on TDD versus BDD, because that's a really interesting topic.
Or add us, namespace_pod on Twitter.
Mm-hmm. Okay, great.
Let's talk about, you're not actually doing TDD.
Yeah,
Let's talk about your experience.
Let's talk about it.
Because you said you were doing TDD and you lied to me.
Well,
I lied.
Okay, so I do unit testing. That's, but
true.
Okay. So yeah,
what do you do?
Right. So my workflow is generally what I'll do. I'll have like 2 files open on the same monitor usually. And it's like, as I write my code, I write the name of a test. So I do write my functionality first, but as I'm writing my functionality, once I hit a certain point in a function where I realize like, oh, there's got to be a conditional here. There's 2 different options that might need to execute. So I go ahead and put in like the names of 2 different tests, like a test to test if the first condition is hit versus the second condition, right? And I'm still reaping that benefit of having your code fresh in your mind as you're testing, rather than writing a whole bunch of code and then having to like dig your way back through it to test it. I'm still able to like identify things that need to be tested as I'm coding, but I do not write my tests first. And
there's one other very important thing that you do.
What?
Okay, so
I make my test fail.
Yes, there we go.
Yeah, because that's the other thing that we were just talking about with TDD. If you write your test first, you can run the test file and be like, okay, it failed.
Yeah, it is starting from an error condition is validating the correctness of your test.
Yeah, this is a very important part of unit testing.
One of the things people will complain about is tests is, oh, well, don't you have to test your tests? Where does it ever stop? You have to test the test of the test, and then you test the test and tests. Test. And when you start from the error condition, you are validating that it correctly tests for something. Because if you're testing it and, there's nothing getting returned, you validated that it is correctly testing something's there.
Right.
And so that's why it's so important in TDD to start from an error condition.
Yeah. So I do technically, when I run my tests, sometimes it fails because I have like a bug and I have to fix it or whatever. But if it passes, I 100% will change the assertion to assert the opposite or whatever to make sure that the test fails at that point. And that ensures that my test is testing what I'm trying to test, that my test will fail if the code is incorrect. So I do validate that, and it probably is kind of like a one-off way of doing that by, because TDD, the idea is that your test would fail from the start because you haven't implemented the function yet. But, that's... At least I'm still validating that the tests are accurate. So I will soon, though. I will write all my tests first, and we'll see how that goes, because it's just kind of difficult for me to think in terms of tests. Like, it's so much easier for me to just start writing code.
And that's why everybody does it that way.
Yeah, no,
it is about the discipline and the standard you hold yourself to. Mm-hmm. But let's talk about as you're coding, especially if you do test-driven development, you get to a point where you're like, oh, I need a test for this condition. Oh, that test should have been there before. People then use that as like, oh, well, so you can never know. You just write your code first, then you write tests until you have 100% code coverage of that function. It's like, that's one way to do it, sure. But if you get to one of those situations where, oh, I should have had a test for this, just add the test at that time.
Yeah.
Like, get it handled. Don't be perfect.
Yeah, you don't have to worry about writing every single possible test that you can think of off the bat. Like, eventually you will want every test you can think of, but you might not think of them all at first. You can add them as you go.
Don't get too dogmatic about it.
Yeah, don't be too dogmatic.
Another quote off the cuff here comes from Patrick Bet-David. Perfection gets in the way of explosion many, many times. So just don't try to be perfect.
I feel that.
Yes, you should.
Yes, I'm a bit of a perfectionist.
So that's Jordan's way of doing TDD. Yeah. I am a more purist of TDD. One of my more preferred ways to do it is something called consume first, test-driven development. Mm-hmm. And this kind of puts an emphasis on the designing of your class or your API where you have to consume the code that is about to be tested before you write the test. And it's going to be really difficult to just speak an example out without writing it down. But it would be something like, add this to the database, or
well, I guess so. It's like you write your function call and you pass in parameters without actually defining the function yet. You already know what the function is going to be named. You know what you're going to pass it. You know what you want back, but you haven't actually written the function yet.
Yeah, exactly. So you want to define how you're going to interact with that function before you write the test for the function. And that helps prevent that scenario where, oh, I forgot to test for this, up front.
Because you already know how it's going to be used. So you already know what options you have for what variables you might be giving it and what you want to receive back and what you wouldn't want to receive back. Yeah.
And it kind of gets you closer to that whole BDD style. But in this case, your users are other developers that would be using your code.
Yeah.
Because if you're writing decent abstractions and other developers are going to use it. So if you did the whole consume first, hopefully you have a really nice interaction for them. Mm-hmm. I don't always do consume first test-driven development. I'll be honest, I don't always do test-driven development because there's some times where it's like, I don't know how I want to structure this. And I just want to prototype something. And then I'll throw a prototype and get something working. And then I'll start doing test-driven development as I fully flesh out the feature.
Mm-hmm. Yeah, sometimes, like it's hard sometimes just to think in terms of the test when you don't know exactly what your implementation is going to be yet, Okay, well, do you have anything else to add about your experience with TDD? I don't know. We have a few more topics with so I guess let's talk about what we consider the TDD benefits, which
well, we already mentioned a couple of them.
We mentioned a lot of them.
Starting from an error condition, you validate the correctness of the test. You get little victories along the way. Every time you see your test pass, it's like, yay, I know how to write code. Yeah. Oh, I broke it. Okay, let's go fix it. Yay, it works.
Yeah, you have, and like we also mentioned, your tests are, you don't have to go back and dig through your code to figure out what needs to be tested, because sometimes it feels like you're just doing development twice. Like you have to go through all of your code again and figure it all out again, when you could just have already completed that part as you go.
Yeah, I'm doing a lot of reverse engineering for work right now. And some of that is adding tests for these just huge, 150, 200 line functions. It's like, okay, I'm guessing at inputs and all that stuff. And I think this is supposed to be coming out having looked at it. And it's like, oh, this fails because this thing's not imported. And it's just like, that is frustrating and demotivating compared to when I do test-driven development of the exact, the new version of this thing I'm reverse engineering. It's just like, oh, this is so satisfying and easy and rewarding. It takes that mental toll off you as a developer. And that's really where the burnout comes at the end of the day, is exhaustion over frustrating things like this.
For sure.
Save your career, TDD.
Yeah, be happier,
that could be
TDD.
A shirt. That could be like a license plate or a bumper sticker.
There's a lot of quotes that could be good for TDD. A lot of people feel really strongly about it. So then I guess we listed a few other benefits that were just like unit testing benefits. I
gotta go back for a minute.
What's up? Go.
Because I gotta use a quote.
Oh, go for it.
That I can be quoted. Yeah. When it comes to test-driven development, right? In my experience, if you are mocking functions that don't cross an architectural boundary, you are not using test data that reflects the data your system actually works with. That's just some general advice for TDD. I don't know why that quote just popped into my head. But yeah, you need to use like data your system's actually going to work with, not random stuff.
For sure. Yeah. So whenever you're writing your tests ahead of time, you have to be aware of what data your system is going to be using.
Right. Yeah.
It's very important.
I had to follow up on some tests where it was supposed to loop over a list of dictionaries or something like that. And this developer was passing in an integer and expecting back something. I was like, what?
Yeah.
Makes no sense. So that is when I came back. Oh, and it's because they were mocking some stuff. But at that point, it's like, does that test really even matter?
Yeah, exactly. You definitely need to be working with data that your system is working with. And that's kind of another sub discussion we're going to have in a minute, is about mocking. Because yeah, that'll happen all the time whenever maybe that function was returning an integer. And so it's mocked to return an integer right now. But it got changed to return a dictionary. And now your mock is still returning an integer. So we're going to talk about mocking, because that can be an issue in code for sure. That's why you got to make sure that in your unit tests, it is always the data structure that your system is actually using. But yeah, we'll talk about that.
Yeah, I think we're going to do benefits of just unit testing in general at first.
Yeah, which hopefully nobody out there's arguing against that. I mean,
I think they do.
I think the only argument against unit testing, well, like in a hackathon or something, people will be like, don't unit test, we don't have time for that. But still. Yeah, no. It'll help.
The very first hackathon that I ever participated in, the senior dev that was on our team and myself, like I added a test file and it had a stub of a test function. And he's like, Derek, I'm so proud of you for doing that. You're the only one that even tried. The only one who even thought of it. Yeah. Also, hackathon code never makes it to production.
Oh, hackathon code.
All hackathon code. Okay, I can't say this because, that's a fallacious argument, but I would imagine all hackathon projects that end up in production get completely rewritten because you just don't have time for quality.
100%.
I hope.
Yeah. Well, I guess just like the benefits of unit testing would be obviously better code, less buggier code. And if anybody is arguing against unit testing out there and you have unit tested before, I would say you should just ask yourself, have you ever wrote a complete file of unit tests that all passed and your code was perfect? It's like, that's so rare. Usually you have to go in and it's like, there's a very minor thing maybe you have to fix, or like a typo in this one thing, or, oh, you got your, if you're using a dynamically typed language, like something was the wrong type, you're like, oh, let me fix that. If you hadn't wrote the unit test, all those would be bugs in production. Maybe someone notices it in a pull request, but oh my gosh, it just saves so much time in the long run if you can catch these bugs ahead of time. And then now in the future, if some developer tries to go change your file and they change something that shouldn't have been changed, the test will fail and they'll become aware of it. So
a great benefit of unit tests is it's just a way to warm up a new developer to a project.
Okay, yeah.
And like, oh, I need to figure out what this function does. Oh, look, there's some tests. Look, yes. I can run them and put a breakpoint, and then I'm just in the context of what I need to be in.
Yeah.
So nice. That's so many times great. I've started on a project that's millions of lines of code, and I'm like, where's the test? I don't know how to get started with this. Yeah,
because if there's tests, you're like, what's this function do? How's it supposed to be used?
Yeah. You have a little bit to go on, and you can start doing the scientific method of, oh, well, what happens if I tweak this? Oh, look, that comes back. That's what I expected. That's what I didn't.
Yeah.
Write unit tests.
Yeah, great to have. Okay, and then, we'll get into the whole integration versus unit testing conversation, which we already talked about a little bit. It's very difficult to define a unit. But I guess I would say for sure, if the test is crossing architectural boundaries, integration. But even if you're staying within the context of a system and you just have so many classes within classes within classes called, even though it's within the subset of the system, it feels like an integration test because you've got so many, if you have so many classes that are interdependent or just depending on each other.
Right. So going back to Uncle Bob's definition of unit meaning small.
Yeah.
And what we've already said of be an engineer, make the engineering trade-off to provide the most value over time. Like think about your tests, is there a way that you can make it smaller? If by making it smaller, are you cutting the complexity of the tests and, you know, making it easier to maintain and understand? And it's like, yeah, cut your test down a little bit. Don't call between those two classes if you don't have to. Yeah,
like use your best judgment. That's really what it comes down to, is using your best judgment in terms of what your unit should be. So
I would say that if you're following the solid design principles, you're going to get to the point where you can cut those down pretty small, almost to the point where it's like a 1-to-1 match, which isn't a goal. Like, I'm not saying make that your target, but I'm saying if you follow good coding principles, clean code principles, you'll get pretty close.
A 1-to-1 match with like classes to tests or functions to test, or wait, a 1-to-1 match of what? You
have a module in Python that's basically a file, and you have a test file for that.
Okay, 1-to-1 match of that. Yeah. I mean, that's usually how my tests end up being, and I kind of just, that's how I format my tests, really. But we there is a quote, I guess we could read the Uncle Bob quote about that. That tests are partitioned by threads of behavior, not by classes. Any given test will often involve many classes within the tested behavior. You may partition your production code with classes, but you shouldn't force your tests to adhere to that structure. But I guess a lot of the times they do end up kind of following that structure, your tests with your classes.
Well, yeah, they do, and they can, and they will. Up at the high level, you'll almost always end up for a 1-to-1 because your test and your production code follow along behavioral lines. But as you dig into the system, your system, the production code, becomes more general in nature, and tests become more specific. And so as you go down, you'll start to see that diverging happening there.
That's a good one. I think
I believe that's an Uncle Bob quote as well.
Yeah.
He went on a tweet storm a little while ago.
I have the quote here. I'll just read it.
Okay.
Because we have a bunch of good ones. Okay.
He has good advice. It's why we follow him at namespace_pod.
On our Twitter accounts. I guess if he has an Instagram, I'll go follow him.
Okay, do it.
Okay. Anyway, here's the quote about that. At the highest levels, the structure of the tests mirrors the structure of the code because they both mirror use cases. But as you descend, the two structures diverge because the tests grow in specificity, but code grows in generality. So that's kind of, you might see your code and your tests doing something similar, which makes sense. And now we kind of get to, I mean, back to like the integration versus unit testing thing, like a unit can kind of just, you can consider it a use case basically for the most part.
And that brings us back to BDD.
Yeah, the use case is like a behavior, but a unit can just be a use case. It might hit multiple classes, but you might not want those classes to hit each other. You might want to like mock one out for certain reasons. Which, I guess, I don't know, to finalize the integration versus unit testing thing, if there's one thing we could say about it, what do you think? I mean, so we already decided it's definitely an integration test if it crosses architectural boundaries. So, and even if your unit test is hitting multiple classes, you're still testing a unit. It's still like a use case, right? Is that what we're...
Yeah, I'd say so.
Okay. So that's what we think. If you don't think that, just let us know. If you agree, let us know, because we're curious about all of these. Like we said, it's very opinionated and
it really
vague topics, but... Okay, so the next one, how extensive should mocking be? Which we've talked about this one again already. I mean, it's so much just like use your best judgment. Very difficult. There are certain clear-cut rules that we think make sense. I don't know. I guess the first clear-cut rule that we had written down was that you don't need to test your. You don't need to test external library functions that are being performed in memory. Like if it's, it requests like an HTTP requests library and you don't want to actually hit the API, mock that out for sure. But don't you can trust that the external library's code is working.
Yeah. For Python, if you have if you import JSON, you're doing in-memory manipulation of strings and JSON strings and dictionaries, basically. You don't need to mock those out.
Yeah.
That's when my quote comes into play. Like you're not testing with data that your system actually handles.
Yeah.
So just make sure you're testing with those.
Yeah. So that's one rule. But then, whenever it comes to over mocking or under mocking, it's like, when you over mock, now you're not working with data that your system directly provides. There are definitely times where you should mock, but it can be difficult if you have a function that's mocked all over the place and then that function gets updated. And now it's not like your tests break or you just have mocks that are returning the wrong value. So it's that can be a challenge, especially on a team of developers. If one developer changes a function's return and they change it in the places where they think are relevant, but they don't realize they have to go update all these mocks, that's a challenge of over mocking. That's a big one.
Yeah, that I've been bit by that one before, where I introduced a bug to production because I had too many mocks. Those were back in my more dogmatic days of test-driven development. But yeah, I would say you should probably only have, max 3 mocks. And that's a lot. That's a whole lot.
Yeah. It is so it's so specific toward the situation though. So that's where it comes to using your best judgment.
I should clarify 3 mocks per test, not 3 mocks in the entire test framework or test suite.
For sure.
Yeah. 3 mocks in a test suite's low.
Right. I think the other really important thing to think about when you're mocking is that your unit tests are a method of debugging. So if a unit test fails, you should be able to pinpoint what caused the test to fail to an extent, because you're testing a unit. So you should be able to go in there and figure out, okay, this unit test failed, where's the bug? Pretty easily. So if you don't have enough mocks in your code, in your test, you're hitting a function that hits this other class, that hits this other class, that hits this other class. And if it goes too deep, that means your unit is probably too big because you won't be able to pinpoint where the bug is. So that's where you should probably add some extra mocks to be able to debug appropriately and reduce your unit to something that would be considered small.
Yeah, I think that's fair.
Yeah, I think that's for me kind of
that or
important.
Slice the unit smaller, like you were saying.
Yeah.
If you're going through 5 or 6 different classes and that top level one fails and like class call 2 or something, you should have tests for the 3 that are even below that. And that's going to help pinpoint. Well, those are still passing. Let's write a test for this class too. Oh, look, now all of a sudden something's failing.
Yeah. The only issue that I see with that is that then...
there are no issues. I said it. I have all the answers. Don't you remember?
Okay, Derek. Well, the thing that to me becomes difficult is that not every developer on the team is going to be aware that the other classes are fully tested. You can go check, you can check every class that got called. So okay, you have a test that failed and it called 5 different classes and you don't know which one. You can go check all 5 classes and see if they're tested and see if their tests cover the base for what was being called in the first test. It becomes it still seems like the unit is too big. Like you're leaving it up to the developer still to have to go and figure out where in the code the bug is throughout a midst of classes. And I do agree that like that is one way to think about it for sure. But also it's like you could just mock that first class call and now you know for sure that the bug is in that first class. But it would certainly just depend on the situation. Like it comes back to you might want both tests. I don't know. It's so hard to come up with specific rules for what should and shouldn't be mocked. But it seems like the pro to mocking the first call to a different class in that sort of situation would be you can pinpoint the error. But the con would be, does your test fully represent the use case, or does it just represent this piece that's like too small? Which, yeah, I guess unit tests could be too big or too small.
Well, yeah, I guess coming into a unit test should test the
like the full use case.
Well, right. So one of our things was don't test like your programming language. Like don't test if your code divides by 0 because we know your programming language is going to throw an exception. About that. But then kind of extending from that, yeah, I guess you could have unit tests that were so small you're testing that the language does what it's supposed to.
Or like you're just asserting that something got called with something. You know, and then it's like, is this really that valuable, or would it be more valuable for that thing to actually get called and make sure that like the integration between the classes is good? But then you can keep going down that path where there's that class calls another class and calls another class and you can't pinpoint it. So that's a very difficult area.
I'll draw a line. I'm comfortable drawing lines.
Okay, what's your line?
In the scenario that was given, calling, the dependent class or the dependency with whatever, you're like, oh, okay, is it more valuable to write a test on the dependency class or the dependent class? Well, if the dependency class needs to limit the amount of inputs that can come to it, that's a valuable test for that. And that tests its use cases. Because a negative use case is still a use case. You are not allowed to use it this way. Mm-hmm. And it should be validated that doesn't allow it to be used that way. Okay, yeah. So that's my line. So I don't think you can have too small of a unit test. Okay. Yeah, so then in that case, you would want to mock the class in the first test in the dependent class because the dependency class has its own test. Or not mock. Well, in this particular scenario, I think you would add a test to the dependency class. Yeah. And you would have to fix the test in the dependent class because it was using data that didn't accurately represent what your system would work with. It was trying to pass a value to a dependency, and that dependency couldn't deal with it, which at this point we now know is an inaccurate representation. And so you would fix that test to no longer do it, not write a mock to accept invalid. And that's the poor use of a mock is when you're trying to support these invalid uses. And it also causes confusion because if you've documented, oh yeah, this takes an int and a string, and then you're mocking it out in tests so you can throw, and dang it, I do it. I like to write a little comedy into my tests. And so very often if there's like a timestamp, I use the day that the music died. If you remember that? No, but it's a song, right? Yeah, well, yeah. It refers to an event of a plane crash where some musicians died. Oh, but never mind. I've heard references to it in songs. Yeah. written by it. But there are songs written about it. I can't remember if there's one titled it. But, sometimes that is out of range for the valid dates that this system can support. But it's like, dang it, that's a nice Easter egg to put in there. And so
it's a good one.
I've done it. I've sinned.
It's good. Well, no, it's in a test. It's good to put stuff like that in a test. You got to pick some date. Why not pick a cool one?
Or exactly. But I'm saying that I've mocked things so that it supports an invalid date because I want to.
Oh, Derek, you're so bad.
So yes, don't do that. But you know, it happens. That's what I'm trying to get at.
Yeah. But I do see exactly what you're saying now. Like, because the test for the dependent class failed, something's wrong with that class or that test because that's the one that failed. And the thing that might be wrong is the way it's interacting with these other classes. But if those tests are not failing, as long as everybody's testing in this same sort of way,
yeah,
then that seems
invalid test data.
Yeah. Wow. I hope everyone followed that.
Yeah, we really need to like have a whiteboard.
Yeah.
Draw some of this stuff.
Yeah, maybe
you can also email us.
Just email us, yeah.
You know, add
For
us
now.
on Twitter at namespace_pod, and I will do my best to explain again.
Yeah.
I think a lot about testing, like a lot.
We've talked about it a lot too. But yeah, so I guess when it comes to mocking, that's kind of going to be our guideline there is you don't need to mock within the system unless you have to. Like if it's an API request that you don't want to make.
Tautology. Yeah, unless you have a good reason for why you don't want to have to do that.
Yeah, like unless you need to make your unit smaller or something. Use your best judgment, guys.
Yeah, but a good reason for mocking is, I don't actually want to make it. Okay, so here's one. I used to I still do ETL platforms.
Yeah.
But we would work with data providers' APIs. And so if I'm running a test for my client for that vendor's API, I don't actually want to be making requests to their API in tests and staging. Right. Like I want to mock that out.
Yes.
And that is a good use of a mock. But if I'm mocking so that I can pass in invalid data and, get test results, then that is not a good use of mocking.
Or like, if you want to mock, I was going to say if you want to mock a class to make sure it returns an exception, but then it's like, just pass it data that makes it return an exception.
Well, there are times where the setup to throw that exception is more complex than it would be to just mock it to throw the exception. And that's another good use of a mock is and initially that's what they were for, is to control behaviors of dependencies inside of this function.
Mm-hmm. So there's another good point is what's easier, what's more valuable, because sometimes adding in a mock and like figuring out how to mock something can be a lot of work, but then sometimes trying to get this dependency to raise an exception can be a lot of work. So you kind of have to balance.
It can also be more confusing too.
And it can, so do your best judgment.
Again, don't be dogmatic.
Don't be dogmatic.
That's what we're saying.
Ask your friends if you can't think about it. Ask your friends and get their opinions.
We don't have any friends. We are antisocial. We don't like people.
Ask your dev team. I don't know. There's a lot of there is a lot of hard consideration when it comes to testing, and that's why it's hard. Hopefully y'all are thinking this through with us and able to learn something and come up with new ideas from us talking, because that's the goal, is that we can all learn something.
Yeah, I mean, we certainly learned a lot.
Yeah.
That we both don't do test-driven development properly.
Yeah.
That neither of us do BDD.
Yeah. Well, okay, so code coverage goals we can hit really quick, which, should I be 100% covered? Don't be dogmatic. It's not a perfect world. Like, have code coverage goals, but it's it kind of comes back to that quote you mentioned earlier, where perfection
hinders explosion.
Many yeah, it's like if you spend forever trying to get this one line tested, I mean, just do your best. Test all the cases that seem like they really need to be tested, that they're like really important potential cases.
Yeah, if you need a goal, I would say above 90%.
That's a good goal. I think
it's a realistic goal.
Above 80% is sometimes a goal, but above 90. Oh my gosh.
What project have you and I ever worked on together where we have a code coverage less than 90%?
Oh no, ours is always above 90.
Okay, don't.
I'm just saying, like,
we want our listeners to hold themselves to the same standard we hold ourselves to.
Yeah, A+ above 90. Okay, and then we already hit some of these points, but just to go back, we'll provide some counter arguments to the TDD is dead or TDD is bad type arguments. One, like, it takes too long. You can't rush quality.
Oh, yes. This is another one of my quotes.
Oh, is it? Go ahead.
Things of quality are rarely finished quickly.
There you go.
Is that a Zenzing or what?
It's a good one, because it's true. It's like, it takes a little bit longer to test your code well. At least it's tested well. That's great. It should be tested well. Like we said before, how you are able to reduce the number of bugs going into production by unit testing. TDD just adds an extra layer by ensuring like your tests are valid, and it is a quicker way to unit test for the most part than writing tests after, because you don't have to dig through your code. I mean, there's so many benefits to TDD and unit testing that it takes too long is not a valid argument against it.
Coding takes a long time.
Don't email us and tell us that it takes too long. We will dismiss that. Well, you can email us. We will just dismiss it though.
She might.
Okay. Some arguments we saw, like TDD doesn't emphasize system testing enough. Well, it doesn't. It's about programmer tests. It's about unit tests.
It's tests by developers for developers.
Yeah, that's what it is.
That's why we have QA teams.
Yeah, so TDD doesn't say don't have system tests. You should still have system tests.
Yeah, it's just a different function.
For sure. All right. And then, the other one that we think a lot of people probably don't like TDD because it's difficult for them to figure out what a unit is. Like, a lot of people just talk about kind of like the dogmatic idea of like what TDD should be and how it should be done and what it's supposed to be. It's like, don't think so. Well, do think hard. Like, it's hard. You have to figure it out, but don't look for a perfect catch-all answer to your questions. You just have to figure it out as you go.
Let's quote Don at this point. The rule of silver bullets is there are no silver bullets.
Okay, there you go.
TDD is not a silver bullet.
It's not.
But we saw some articles where people are like, oh, TDD is not a silver bullet. And I, for one, have never heard somebody say that. Yeah. I'm sure there's people out there that have, but yeah, like, duh.
Yeah, it's not a silver bullet. That doesn't mean it's bad. It just means it's not a silver bullet. It's not supposed to be. Okay. All right. And then, we started an argument. TDD is not about test correctness. Or wait, it's about test correctness, not about code correctness.
So it focuses on passing tests, not correctness. That was the argument that was made. Mm-hmm. And that's somebody that's doing TDD wrong.
Right.
Because if you're starting from an error condition, you're writing that based on your functional requirement, your user requirements, your specs, whatever. And however that fits into the larger picture of things. And then, yes, you're focusing on making that test pass, but it started from the error condition of an actual requirement, which is correctness.
Yes.
And so anybody that has that issue is working with people that aren't doing TDD correctly.
Right. Your tests should be validated because they should fail. Okay. Last comment, which will bring us back to the main topic of this episode. People who argue against TDD are very upset about obsession over code coverage and obsession over mocking and obsession over integration versus unit.
It's a very opinionated topic. And I know because I was very opinionated for years. In fact, I basically ran myself out of a team because I was so dogmatic about how we test. But yeah,
Don't
be dogmatic.
Yeah.
Ta-da!
That's it right there.
Wait, is that a silver bullet? Don't be dogmatic.
Yeah.
No. I won't curse it that way. I'm not going to say that.
Yeah. Okay. Well, that's everything. We did a lot of really hard thinking to try and come up with our actual opinions on all these things, because it's very difficult sometimes it's so vague and generic, but these are our thoughts.
Yeah.
And thank you guys so much for listening, and email us at namespace.pod@gmail.com. We'd love to hear about what you think about TDD or BDD, mocking, integration, unit, anything you want to talk to us about.
And definitely check out the Twitter at namespace_pod. We already have a couple of tweets out there. We're following a couple of really good people.
Yeah. We have an Instagram. I don't know if it's as popular yet.
Well,
I'm doing
our Twitter's not popular yet either, but there's content. I don't know about Instagram.
I'm working on it. But yeah, you can find us online. We'd love to connect with you guys and continue this discussion. So yeah, thank you so much for listening.
Awesome. We're out.